Hello, welcome back to video 3 for domain 1. And this one is understanding number 3. So here's some ideas you may see as you go through these types of problems is to analyze the group structure of real numbers, use complex numbers and their operations, analyze the properties of numbers and operations, apply the principles of basic number theory. Okay. So we'll go through a few examples again, just to give you an idea of this part of the domain 1 and see, hopefully it helps. All right, so in our first one, we're dealing with if P and Q are prime numbers. So we need to make sure remember prime numbers. And 45 over Q3 equals P squared over 25. What is the value of Q minus P? Okay. So there's a couple different ways we can approach this. One is maybe we try to solve or get it into a different form that might be a little more helpful for us. And we have a fraction equal to a fraction, so we can go ahead and multiply here to multiply both sides by the 25, multiply both sides by the q cubed, and see what we get. So we would get 45 times 25 equals q cubed times p squared. Okay. So now we have a product equal to a product, which might be a little easier for you to work with instead of a quotient equal to a quotient. And what I notice is we're dealing with prime numbers here. So we know that P and Q are going to be prime numbers. So right now we don't have prime numbers. So let's go ahead and prime factor these and see what we get. 45 is 9 times 5. 5 is good. 9 is 3 and 3. 25 is 5 times 5. So we have it down to the prime factors, and it's a product, so we can write this as 3 times 3 times 5 times 5 times 5 equals q cubed times p squared. And hopefully you're seeing that, well, 3 times 3 is 3 squared. 5 times 5 times 5 is 5 cubed equals q cubed times p squared. And from here, we can see that we're set up with the same powers. We have prime numbers, so we can make that conclusion here that q is just 5. So q equals 5. And p, since they're both squared, p equals 3. And we're asked to find q minus p. So we have q, which is 5 minus p, which gives us 2. So our answer here would be D. So with some of these, it's helpful to maybe just move them around a little bit. Use your operations that you know are legal steps, move things around and see if you can get it into a form that maybe looks a little better to you. Okay. Let's see what else we have. Okay, so which of the following is not an example of a real number? So this is more of a definition type of problem. And we want to deal with, remembering real numbers are rational numbers or irrational numbers. These are examples of types of real numbers. A not a real number would be an imaginary number would be our option here. So let's look at this, and I sort of typed it all out nice for us so we can look at it. And so the first one, A, -3/5. This is a real number. It's a rational number. It's a fraction. So that one should be eliminated pretty quick from your options. B, the square root of 2 is an irrational number. If you remember, that's going to continue on forever. It's not going to have a pattern, so you can't put it into a fraction, but it's still a real number. And same idea with D. You have pi in here. So pi is an irrational number that same idea. We're not going to be able to put it into a fraction, but it's still a real number. And then C, it has the I in it for the imaginary number, so that one should be pretty quick to give that away, that is our choice. Um, C is our option for not a real number because it is an imaginary number. So you want to be good with your definitions, number sets, those types of things. Okay, one last one to go over. It's a little refresher on dealing with simplifying imaginary numbers. So here we have a fraction with an operation in it, 4 minus 5i. And when you're simplifying imaginary numbers in a fraction like this, you want to use the conjugate. The idea is you're trying to get rid of the imaginary number in the denominator. And to do that, you want to use that difference of squares. So let's see what we have here. So we're going to multiply this by 4 plus 5i. So that's going to get us the square of each of these, which when you square an imaginary number, you get that -1. So that removes it from the denominator. And whatever we do to the bottom, we're going to do to the top of the fraction, numerator and denominator. And from here, it's remembering your FOIL and then remembering how to reduce, simplify our I squareds. So we'll just go ahead and work our way through it. So we get 8 plus 10i plus 12i plus 15i squared. All divided by. On the bottom, here's, maybe you can see it already. We have 4 times 4 is 16. That's good. 4 times 5i is a plus 20i. Negative 5i plus 4, or times 4, is a negative 20i. So you can see how these are going to reduce out. Negative 5i times a 5i gives me a negative 25i squared. So common mistakes with these is sign errors, those types of things. But what we should notice is these center two terms are going to drop out, plus 20i minus 20i. And then we have to work with these I squareds. So we need to remember that I squared equals -1. And remember that comes from I equaling the square root of -1. So if you square both sides, you get I. I squared equals -1. So over here, this is really plus 15 times -1. And this is negative 25 times -1. So when we combine these, we have 8, go the long way, minus 15. And then we can add these 10i and the 12i to give us plus 22i. On the bottom, we end up with 16 plus 25. Yeah. So if I subtract these, I get -7 plus 22i over 41. And we can start to see what order they want us to go in. So we have denominators of 41. We have the I, that's good, 22, but we have 23 here, so that's not our option. B, that's broken apart, which is another way to write this, right? We can write -7 over 41 plus 22 over 41. And we have our I. And so B ends up being our option here. So again, with this one, it's going to be maybe moving too fast, making a sign error, those types of things. But I think if you take your time, you should be okay with these. All right. Hope that was helpful. And have a good day.